What about wireless? How does all this work for wireless? Very similarly, MTSOs are like central offices. They get connected to those giant antennas you see. Those antennas produce a radio signal roughly in the form of a cell, and so it's called cellular technology. And those connect your phone. As you're driving or moving, your phone is monitoring the strength of the signal from each cell tower. And the software in here switches your phone to the best signal available. And again, these have gotten so good that we rarely drop calls on our cell networks. And these also connect to the normal network so we can all speak to each other. If you're in the city, the cells are smaller. Why? Because there's more calls. Each radio frequency can only support one call on an analog system. And so the cell has to be smaller because we reuse frequencies. So if you're out in DeKalb, you can have a big, giant, tall tower with big signal, a big cell, because we can the finite number of radio frequencies on that cell are fine for the smaller number of people. So here's a picture. We've talked about analog, the human voice, the wave, and digital is on or off, 1 and 0. Ones and zeros, just like with packet switching, allow you to do a lot more things to help your quality and cost. And really, the costs have come down. They have not passed all the savings to us, the consumers, but the costs have come down. The main thing is something called multiplexing. And multiplexing allows, because of the software manipulation of the ones and zeros, allows more than one call to be on a single radio frequency. So you don't have to build as many towers. You can do more by putting many calls simultaneously on one channel. So what about all this G stuff? You might say, I have a 4G phone, or I just got a 5G, I'm paying for 5G. What does it mean? G is for generation in telecommunications. So Alexander Graham Bell was the first generation. Once you got to digital, meaning ones and zeros, that was the second generation. 3G was faster, with higher capacity. There's some of your numbers. 4G, and sometimes called 4G LTE, long-term evolution, is faster still. 1 billion bits per second. 5G is currently the fastest, up to 20 billion bits per second. When that is achieved, you're going to see these cell towers becoming your ISP. You will not need Xfinity or a cable provider to be your ISP if you can get that much speed from your cell provider. But be careful. They'll sell you 5G, but you don't want to, if you're on a low frequency band, you're paying for something and not getting the correct speed. So you got to be careful that you're really getting the speed you're paying for when you're dealing with your telecommunications providers. So to answer this question, if Verizon said I'm going to have an all digital network, all that you would know for sure is that you're going to be in ones and zeros and you're at least second generation. If that was the promise, that's all you'd know. Here's some capacity, BPS standing for bits per second. Twisted wire, I'm going to go to the next slide, is this. 2 copper wires twisted together. That's normal telephone service. microwave, satellite, coax, that's cable, fiber. Here's a picture of fiber, glass strands with really high capacity. Here's the transmission capacity of these media types. Very important. We talked about the modem in our 6-box diagram, and it allows the normal telephone network to participate on the internet. There's analog, there's digital. Great picture. Grandma has a computer which speaks in ones and zeros, but Grandma is connected to the PSTN, which speaks in waves, which transmits information in waves. So if she wants to send an email to someone, she takes her ones and zeros, here's the modem, it converts it to waves, it goes over the network, converts it back to ones and zeros, and her friend can read the email. So modulate is digital to analog, demodulate, analog to digital, so a modem makes the conversion and back again. So we can all communicate. And you end up with a giant hodgepodge of media, connectivity, converters, switches, routers, and it's amazing how well it all works. Here's the acronyms for networks, mostly defined by geographic area. The internet or the web is the only true global area network. A local area network is going to be like in your department or in your building. Wide area network, like we saw in the picture, might be connectivity between two companies. And a metropolitan area network, I believe Naperville provides free Wi-Fi downtown, so that would be a metropolitan area network. But here, that's the internet and the web. Topology is the structure, a centralized star, or a decentralized ring and bus. That gets a little techie. We've talked about protocol. That's the rules, the standards. We've talked about TCP/IP. Ethernet is a protocol for local area networks. GSM for cell phones, etc. As a manager, you just have to know that this exists and could affect you. Then some brilliant person said, boy, this internet thing is working really well. Everybody likes it. They're using it successfully. Let's use it privately. Let's take a smaller version and use it as something called an intranet. So it's used privately with the same technology, and it makes it real easy for a company to have a nice little network, but then they want to make it private. How do they do that? Remember, they use a firewall. Then somebody else said, well, let's do an extranet. Let's use the technology of the internet to connect with our customers, business partners, and vendors. Great. So there's a picture of an extranet. We have these people, they have connectivity to the internet. We have our little moat, our firewall, and then all of our partners, customers, suppliers, and business partners can utilize the resources of our network if we give them a username and a password to get through the firewall. What's missing here, though, really is the picture of an intranet. So if we took this picture and said, well, which part of this is the intranet? And once again, I'm going to use my pen. It's this. The intranet is our internal network. This is the public network, the internet. So there's the intranet. And again, we allow these people to participate with a username and password, and then the whole thing becomes an extranet. So there's where the picture would go. VPN, very similar to an extranet. Here's a picture of all three. And then backing up a little bit, the internet started back in 1969 by the Department of Defense and education institutions. Now, business has basically taken over. But this causes trouble for things like taxation, illegal gambling, etc. It was intentionally designed without a central authority. The reason was the Cold War was happening, and we were afraid that Russia would bomb us, and we wanted the network to continue functioning if one or several servers got bombed, which is amazing to think about it. Business likes central authorities because you can tax business and governments, really. But the way the internet was constructed as decentralized has made these sort of things harder, and these rules are still evolving. The World Wide Web has all of these capacities. So it's a physical entity, common protocol, still holding on as being neutral through a concept called net neutrality, meaning all internet traffic should be treated equally. Once businesses got their hands on things, they wanted to start charging the big companies, letting their traffic have preference, charging them more or whatever. And net neutrality says, no, this is designed to be a free and equal place. How many internet users? Look at the progression. That's 1998. And then look at 2020. 60% of the world's population. Still, by the way, we're going to need to get that. If we want to be fair, we're going to need to have everyone connected. That's an ethical concern. What about servers? Those are the web servers. Look at that progression. And if you chart the rate of growth of servers, you will find that the rate of growth is faster than the rate of growth of users. Now, why would that be? Well, what's happening is people are starting to realize it's advantageous for them to control a server, or at least to buy space on a host like I do at GoDaddy. That helps me run my classes. So servers are accelerating, where more and more business users are realizing they want to take control. IP address is a numeric address, like a telephone number, that indicates where a computer is on the internet. But in the case of the internet, they went the extra step that telephones still have not, which amazes me, of using the DNS, the domain name system. So instead of saying go to 131.40.5.201, I say go to chuckdowning.com. That's because of this. Wouldn't that be nice? Instead of giving somebody your phone number, you could just say call Chuck Downing. They haven't done that with telephones, but they have with the internet. And I highly recommend that if you have a business idea or a unique name, you purchase it. You can buy these for about $9 a year. That's about what I pay for chuckdowning.com per year. It's one of my students' favorite recommendations over the years, saying just go buy your name and hold on to it. You don't know when you might want to use it. And then the e-commerce models, business on the internet, we have business to business. That's the biggest one by far. Business to consumer, consumer to consumer, etc. And clearly the biggest business to consumer is Amazon. That goes there. Challenges. 60% of users still consider it unsafe. That's generally the older folks, but that's a problem. Talked about no central authority, protecting privacy. These are still challenges that you will face as business managers ongoing. And then with all this information flying around, we talked about bad entities. We have to protect it. So just the end of this unit talks about protecting it. This is a true story where one of the programmers in a bank took the third digit, that, if I can highlight just that third digit, the 4, took that digit and directed it to his account. No one cared. You don't care about 0.4 of a cent. But he directed it to his account and made a ton of money. There's so many things that can happen with technology in the security spectrum. Look at this range. That's like if you emailed me and said, Dr. Downing, can you estimate my grade for OMIS 351? And I said, yeah, I think you're getting somewhere between an A and an F. That's not a helpful estimate. This is a $285 billion range. So this question says, why so large of a range? 2 primary reasons. One, they often don't know they were hacked. Companies don't know they were hacked. And 2, sometimes companies don't report it. Companies have experienced problems in the past where they reported being hacked and lost customers. So it's become kind of like a dirty family secret. They don't want to tell. So it's either they don't know or they don't tell. And so we have this crazy range where we're not really sure how big they are. Crime is certainly not the only security area. It's the most talked about because it's exciting, it's interesting. The one that costs the most money is right there. People forgetting to back stuff up, people accidentally deleting stuff, etc. And systems limitations means things like your hard drive goes bad or your flash drive won't open. These are all major concerns. Make sure to read the TJX. TJX is the parent company of TJ Maxx, Marshalls, Home Goods, and others. Nice business case in your textbook. Some very good lessons. We're going to codify those lessons into 2 major areas: people and technology. People is your best line of technology defense. You need to remember that as a manager. You have got to have your people on your side. 33% originate inside. So if you can get people to help you and not do bad things or dumb things, it is to your advantage. How do you do that? Develop policies and plans and make those clear. Warn your employees about social engineering. The bad entities are trying to trick you. So you're getting spoofed emails. What's a spoofed email? It looks like it's coming from something real or something legitimate. And it says, click this link so your account can stay in force or whatever. I get these all the time. Most of us get these all the time. And so here's the answer on spoofs or anything else. If you're ever in doubt, this is worth the price of admission to the class by itself. If you are ever in doubt initiate the action yourself. There you go. What does that mean? So I get an email from my bank that says, we need to secure your account. Click here. Anyone can spoof an email from anywhere. I could send you an email from your mom. The technology is not difficult. So if you get an email like that, never click on the link. But then, of course, the problem is complicated by the fact that some of these emails are real. You don't want your bank to close your account. So the rule is initiate the action yourself. So if I get an email like that from my bank, it's like, wow, this really looks like it might be legitimate. What I will do is either go to the website, chase.com. Very difficult to spoof a website. That's my bank. So I would log on to chase.com and go to the message center to make sure that email that I received, so when I did not initiate the action, I want to make sure that's legitimate. Or I could call them on the telephone. In either case, I am initiating the action. So I got a call one time that says, this is the IRS, we need to talk to you. And I said, okay, I'm going to hang up and I'm going to look on the web and find the telephone number for the IRS and I'm going to call. And they said, fine, that's smart. So I knew they were legitimate. If it's somebody that's a hacker or a bad entity, they'll start getting mad at you if they're on the phone with you, or just delete those emails. It doesn't mean that your account was hacked, because anyone can spoof, and they just send it to a giant email list, and we're all on all sorts of email lists, unfortunately. It's very hard to keep your email address private. So that's the major form of social engineering. You don't want to be tricked into giving somebody your password or clicking on the link. The way you avoid that is be suspicious of everything. And if you're trying to decide, is it real or not, initiate the action yourself. Technology. 3 primary areas: authentication, prevention, detection and response. This is, are you who you say you are? Usernames and passwords. This is firewalls, the moat around your castle. And this is, oops, somebody broke into our castle. What do? Most popular response, antivirus software. That's a high-level summary. Here you go. Some sort of combination. This, number 3, is called biometrics. Fingerprint, iris scan, voice recognition. These are all very good methods, but also the most intrusive and the most expensive. So this question, the most common is right here, username and password. The most effective is something like biometrics. Very hard to fake somebody's iris of their eye. You can give them something as another way to be secure. And then biometrics are the best, but also the most expensive and intrusive. Content filtering, just make sure you don't get bad content. Encryption means scrambling. We have a slide coming up, and we've discussed firewalls. There's content filtering. There's encryption. The picture's better. The sender scrambles it, so even if somebody grabs your message, they can't understand what it is. If a website starts with HTTPS, if there is an S on the end of it, that means that website is encrypted. The S stands for secure. So that means even if you entered your credit card number on that website and some bad entity intercepted it in a packet, it would be scrambled, and so that person would not be able to see your credit card number. So that's a very good thing. Talked a lot about firewalls. It's the moat. We put it in front of our private network. There's a different picture of the same idea. And if somebody gets into our castle, we got to treat it. And the best way we know right now is antivirus, or you can wipe the whole system. Windows 10, for example, has a utility where you can just wipe it and basically reset it. So when I get too much malware, which is, the pop-ups, every time I click on something, a new ad pops up and it just gets really irritating, I will wipe the entire machine. I am only able to do that because I keep my intellectual property, the stuff that I create, on a flash drive. I like that strategy. Then I can just clean the machine, start again, but I still have all the papers and the spreadsheets and the pictures that are personal to me on my flash drive. And then I back up that flash drive to various other places. Here's some things that might get in. We've talked most notably about spoofing. On the procedure side, don't let the guy put the money into his own account. Separate duties, separate power, continually watch out what's happening in your organization. This is a brilliant idea. Well, this is becoming commonplace. Just like you have accounting audits of your financials, you will have information systems audits to make sure you're not giving information away. That's almost required in corporate America now. But this is the brilliant idea. Your people know what's going on in the organization. So say something like free iPad to someone that makes the best security suggestion. Get them involved. They'll tell you, oh, Bob is leaving his password file wide open on his desk every day that he leaves work, or whatever it is. And right here, this is important, whether you're an individual or a company. What if today is the day that my flash drive just says device not recognized? What if today is the day that a plane crashes into our building and all the information is lost? You better have a plan. The most important part of that plan, the critical part to begin with, is to have off-site backups. So even my flash drive, which has all my class information and everything, I keep copies in my office at NIU, I keep copies at home, and I keep copies on both of my laptops. So it'd be very hard for me to lose that information because I have multiple locations and multiple devices. So that's the basic level disaster recovery plan. And you can use artificial intelligence to help you see funny activity. On the physical side, remember that all physical devices will fail. So again, you better have that plan. You want them secured, separated, off-site backup and storage. And when I say files here, you don't have to back up Microsoft Office. You can get a copy of that later, but your 200-page proposal for whatever your work is, that is going to need to be backed up because you can't just go buy that again if you need to. And fault tolerance, UPS here means uninterruptible power supply. So if you've got networks that are running, computers that are running that need to be accessed by you or your client, make sure to have a secondary source of power. And that was a long one. A lot going on in telecommunications and connectivity, a great unit, but that concludes our discussion together of Unit 4.